Right, well we're back with another video with GEEKOM, where this time they've sent me the new IT13 MAX, which to be fair, after they told me what this thing was going to cost and that you're getting 24 gigs of DDR5 RAM with it, I was a little bit taken aback, so I said, sure, I'll run it through the benchmark suite. So why don't we get this open and take a look at what we've got. So this is of course part of their IT series, part of their workstation line. I'm a big fan of these because, well, I use one every day. Already on the back we have a brief idea of the specifications. The IT13 MAX, you get the Core 9 185 Ultra. I'm a big fan of that chip, seeing as I use it so much. 24 gigabytes of LPDDR5 and half a terabyte of M2 storage. Makes sense to have that much RAM. It is a workstation focused device, but I'm sure we'll run it through the entire benchmark suite. So what exactly do we get inside the box? We do get the IT13 MAX Mini PC, big workstation aesthetic. You get the 4 USB ports on the front, audio in and out. Can't forget SD card reader, very important, especially if you're doing media work. Ah, right, this is interesting. So one part I've always noted about GEEKOM is you can do a full offline Windows setup, no need for an account. And just to let you know that, they've blocked off the Ethernet ports before you plug it in to tell you that you can do an offline setup. Rather useful for letting people know. I've always been a big fan that you can just get straight into using these. In terms of rear I/O, it's exactly what I expect from GEEKOM. 2 HDMI ports, 2 Ethernet ports, 2 more USB ports, and 2 USB-C ports. You can of course power it over USB-C, that's something I'm doing myself over there, and it does just help keep cables down. Not that exactly you need all too many of these to get them running smoothly. We've got our HDMI cable, the lovely thank you for your support envelope, instruction manual, which of course there's not all too much to do, you just need to plug it in and connect up HDMI, but well worth including. A BSY 120 watt adapter, which will handle boost loads absolutely fine. And you can't forget a VESA mounting panel, just to try and keep your workstation tidy. But anyway, let's get this all plugged in and see what all the fuss is about. So if we get this all connected, it is as simple as 2 cables. Once again, this is one of the reasons I love these types of things for workstation use. HDMI, power. That's all you need. And that is the setup, which is why I like these. I wish my actual working desk was as clean as this. So you can actually keep quite a contained setup, like I've got over here. The only thing is, I have tons and tons of stuff around mine, but you can keep it cleaner than that. So let's see, this should now be turning on. It is absolutely silent, and usually these are at the Windows desktop in no time. So we're now at the setup screen. Let's see how long this takes. I should have got a stopwatch, but we're now at 20 seconds. Now up to 1 minute. 1 minute and 5 seconds to actually get to the desktop, which isn't too bad. But of course, people will be kicking me if we don't start with the most crucial of tests, the can we make it slow down. But a quick look at the specifications first. It's a lovely view with the sunlight streaming in. You get the Core 9 185H, an excellent chip I must say if you're doing anything regarding workstation tasks or video editing. I use one of these for video editing all the time. You do get the 24 gigabytes of LPDDR5 RAM running at 5,600 mega transfers, actually very nice, and it is using 8 out of 8 slots, so it's running in dual channel, I'll tell you that much. You've got the Kingston SSD, NVMe, very quick. NPU for AI boost, quite useful if you're running OpenVINO or any audio tools, we will test that later. And you do get the Intel Arc graphics. It's not the most exciting thing in the world, but it is rather good. So we will do a little bit of gaming as well. I know that's not what it's designed for, but occasionally I've been known to use them for gaming. I'm quite a fan of Intel Arc. Still, I will go online and we'll let it do any updates it wants to do. Once again, the Wi-Fi compatibility is actually better than their last model. This PlusNet connection usually gets about 3 bars for me in here. I'm up to full bars, so it is the Intel Wi-Fi 7 BE200. However, by the looks of it, it looks like they've taken this exact same chip and they've just improved the antenna on it, because that's doing better than I expected. Already off to a good start. Anyway, we'll let it do whatever updates it wants. It's doing a few things in the background, and then we will try and make this slow down. In fact, why will we even wait for the updates? Why don't we just try and make it slow down while it updates? Give it even more of a challenge. To make things a little bit more challenging, we are going to go straight in with 2 drives for it to pull for I/O, just because I don't think it's going to slow down installing from just one location. So an M2 SSD here, and a standard SATA SSD here, both of which is going to be pulling data from to install files. Let's begin. So if we start with getting our usual MSI Afterburner stuff set up, we start getting hardware monitor set up, we start getting GPU-Z set up, CPU-Z set up. That was done before it even began. Yeah, it's another case of it's a bit tricky to get the thing to slow down because it can go quicker than I can click. But that's a good test. If you can't physically go quick enough with your clicking to make it slow down, it kind of gets the point that I'm talking about across. One thing I do want installed is I do want my video editing software. So we definitely want to get Serif Movie Plus X6 on here because this is my video editor of choice and it is absolutely brutal on single core performance, especially when applying certain effects. It's one of the reasons why I've been able to upload so frequently and in 4K is because I use something from GEEKOM with similar specifications and it blasts through video editing. It genuinely doesn't struggle at all. How are we doing? 14% with perfect 4.2 GHz boost. We will look at the sustained boost clocks in a minute. In fact, while it's doing this, it's a good opportunity to take an initial look at thermals. It's one area that GEEKOM really does excel at, is keeping these boosting high but not too hot. So yeah, we're looking at peaks of 80 degrees while it's installing multiple programs, which, you know, for your day-to-day tasks, it's hovering in and around 50 to 60, which is more than fine. Yeah, so if you are trying to stress things out with your day-to-day workings, about one core is going to actually boost up. You can't make it slow down with day-to-day tasks. It's going to need something a bit more intensive than that. Let's leave that doing its thing. And then the last thing I do want to check is, can it sustain its boost clocks? Because that's one thing that GEEKOM's always been very good at, is sustaining boost clocks. So for example here, we can see that when it needed to, it boosted a single core up to nearly 5.1 GHz boost. So I've run through a quick TimeSpy benchmark, and to be fair, out of the box, we have got some rather respectable scores on both the graphics and of course the processor. But the bit you'll be interested in is the out-of-the-box thermals, where we saw a peak of 79 degrees across all cores, while it was boosting at 127%, which is 4.7 GHz. So yeah, sustained boost, not a problem. In terms of graphics card load as well, when it's actually running through the benchmark, it doesn't really fluctuate too much. Towards the second stage, we do see it lose some clock speed, but that's not exactly the end of the world because it boosts straight back up, so it might just be because it wasn't needed there. So yeah, in terms of out-of-the-box experience, easy to set up as we expected, offline setup easily available, and it's not going to thermally throttle and overheat, even if you stress it out with, of course, 3D Mark and installing applications in the background. But anyway, it's time that I got on with getting some real data together and going through the rest of the benchmarks. So, just what are the full specifications of the GEEKOM IT13 MAX? Well, this 2026 edition comes with a Core 9 Ultra 185H with 6 P cores, 8 E cores and 2 LE cores, which can boost up to a total of 5.1 GHz, which we know it can do because we've seen it do it when we're unzipping simple files and bits and pieces. The single core performance is one of the reasons why I do kind of love the Core 9 Ultra 185H, especially in older applications, which I tend to use quite frequently, given that I actually edit on a GT1 Mega PC from GEEKOM, which has very similar specifications to this. Graphically, you get an Intel Arc Meteor Lake, which is a very solid graphics card, not saying you'd expect to have the gaming prowess it has given the workstation origins of this PC, and you do get 24GB of DDR5 LP RAM. It was released in 2026, you do get half a terabyte of NVMe storage included, and you can add plenty of your own external storage like I've done today. At some points today, I've had 3 SSDs plugged into this, which work absolutely fine because there's a lot of expandability and lots of USB ports. It runs Windows 11 out of the box, and for a workstation PC isn't too badly priced, coming in at $799, and I'd imagine a similar price in pounds and euros. Generally, when you're considering this is a bit of a powerhouse for workstation tasks in a little package, I mean, I can kind of vouch for what they're going for here, given that I use something similar to this every day, and I do understand the appeal of the form factor, having that much power crammed into it. Over in the world of synthetic testing, if we start with a breakdown of a 3D Mark TimeSpy benchmark, we can see that the CPU pulls ahead clearly with a final score of 10,973, the graphics card returning a very respectable 3,372, resulting in a total score of 3,762. So yes, we have a clear CPU side bias, but we are using an iGPU here, but still one that returns a really rather admirable score in a DirectX 12 benchmark. When we look at CPU performance, you can kinda tell why I love this. The Core 9 Ultra 185H, especially in the GEEKOM IT13 MAX, outperforms even a full desktop Ryzen 7 3700X, while also being in a much smaller power envelope and a much smaller package. So yes, it is currently topping the charts with 10,973, and if we move on to the graphics side score, for a little iGPU we can see that it has improved over a base Meteor Lake score of 3,724, and thanks to rather adequate cooling and good power delivery, we're now up to 3,762. So Intel Arc's Meteor Lake, despite being an iGPU, is actually delivering rather decent mid-range performance. When we actually look at a progression through 3D Mark benchmarks though, we can see a nice linear progression from the early DirectX 11 Firestrike, gradually working our way down to Speedway, which of course is a ray trace enabled benchmark, where we see that that is about the limit of the system. So it'll be able to handle most DirectX 12 into the entry level, some of the more intense DirectX 12 games are going to begin to struggle, and ray tracing can be done, but it's probably not recommended. Now, I have got a lot of workstation-focused testing coming up later, but I do want to run this through the benchmark suite, because given the value proposition on the table, as a workstation, it's gonna do very well. We can already tell that from the specifications. But what if you wanted to do a little bit of extra gaming? See, given that I use a very similar system to this every day, I know that I do get away with playing a few titles on it, some that are more intensive than you'd expect, because the Intel Arc iGPUs are relatively powerful, and given this new IT13 MAX is already showing us that it has, well, higher than average scores, at least compared to the previous units we've tested, then it does mean that we should be able to eke out some quality gaming performance. So I've gone through and done a few benchmarks, probably more than I should have done, because I was continuously impressed by the Intel Arc graphics, and there's only one way to see how it's going to perform, and that is with the benchmarks. Starting off the benchmarks, we have GTA 5 Enhanced Edition, which we ran with high and very high settings in 1080p. Now, if you are going to be playing GTA on a device like this with an integrated Intel Arc iGPU, then the Enhanced Edition really is the version you should be going for, because DirectX 12 really does seem to work well on these Intel Arc-based cards. We returned averages of 47 frames per second, with 1% lows that were very slowed down to just 43 FPS, and this is the big takeaway here, is you don't have to go about capping the frame rates in any instances, because the power delivery is set up pretty much perfectly, where you will get sustained boost clocks on both the CPU and GPU, and not have to worry about seeing good performance for all of 15 seconds, and then suddenly it plummets below 30 FPS. No, this is the frame rate you'll see from the moment you launch the game through to 2 hours time. Moving over into the world of GTA Online Enhanced Edition, we saw our average did dip slightly by 3 frames per second, and pretty much the exact same in 1% lows. Makes sense, it is slightly more intensive, especially on the graphics card, and given we are using integrated DDR5 memory, then it does mean that we are limited on memory bandwidth. But still, you're going to be getting a playable experience, and you could always turn down some settings if you wanted to get a higher frame rate. Next up we have Counter-Strike 2, where if you are playing this, you are best using the competitive resolution of 1280 by 960, or you could run it in 1080p, but you will see slightly more unstable frame times. It's still doable though, and with competitive settings in this resolution, we saw 133 FPS on average, and 1% lows down to 119 FPS. Once again, the stability of the 1% lows can't be understated, because it just works so well. Counter-Strike 2, when we move into the world of Cache, which is one of the more intensive maps out there, we did see a noticeable dent to our frame rate, losing around 40 frames per second. However, we still retained our really rather solid 1% lows. It's worth noting this was done in an offline match, however you would see very similar results when you play online, given that we weren't really CPU bound in any instances, and given this can boost up on the cores where it needs to, it means that you do have the headroom there to stop frame rate drops. So Counter-Strike 2, in virtually the most intensive instances or the lighter ones, you're going to be getting a playable and actually pretty smooth frame rate. This is the first opportunity I've had to look at BeamNG's version 0.39 update, where, well, it is intensive, but then again, BeamNG has always been particularly brutal on these iGPUs given how much it loves memory bandwidth. But with normal settings with the traffic enabled in the jungle map, we did have to drop our resolution down to 720p. The game still does look absolutely gorgeous after this new update, and we were able to return averages of 40 frames per second and 1% lows down to 36 FPS. It's worth noting that in simpler maps or without the traffic enabled, you could up the resolution, but frankly, I like stressing this game out as much as possible on most systems to get you sort of a real-world gameplay figure. So BeamNG's latest update, you're going to have to drop down to a 720p HD resolution, but you're still going to get a playable frame rate, and given the CPU processing power you've got available, physics effects aren't really going to slow things down. Arc Raiders has a really good implementation of Intel's XESS, I'm not really sure how you're meant to pronounce it, but with the balance mode and a mixture of low and medium settings, which is how the game actually launched with its defaults, it does get in and around the 60 FPS mark when not much is going on. Generally though, in actual combat and real-world gameplay, you will see an average of 50 frames per second and 1% lows down to 41 FPS. It's worth noting that FSR on balance would perform ever so slightly better, some slightly better 1% lows, but did not look anywhere near as good as Intel's own upscaler. So if you are playing Arc Raiders, Intel XS actually does work really good for upscaling the game, and you get a decent frame rate even when you're in combat. So Arc Raiders, I can't really fault it here. But this is what I mean. I know this is a workstation-focused device, but you can get away with a lot of gaming you wouldn't think you're going to. Now, it's by no means a gaming machine, but the fact it's able to launch Cyberpunk 2077 with medium and high settings in 1080p, yes, we were using excess upscaling, but I had this set to quality rather than balanced, because there wasn't really much of a performance hit moving up to this. I don't know why, but still, it looks pretty good, same as it did in Arc Raiders. Intel XS does seem to have the edge when it comes to image quality over upscalers like FSR3. And with this, we return an average of 33 frames per second and 1% lows down to 27 FPS. It's worth noting this figure pretty much didn't change. It didn't matter if you were in combat, running around, just getting up to nothing, it would stay in and around 30 frames per second. So really what I'd say is cap the frame rate externally and enjoy a very console-like experience, but with higher visual fidelity, which is pretty good going for a workstation-focused device. As we all know, Oblivion Remastered is almost one of the worst optimized Unreal Engine 5 titles. It's not actually the worst, because it will launch on a lot of stuff, but whether or not you're able to eke out playable performance is another matter entirely. This game loves memory bandwidth, and frankly, we have integrated DDR5, and it's just not giving us enough here. With low settings in 720p with FXAA enabled, we were able to get around 27 FPS on average. Occasionally it would stay above 30 FPS, and then you'd turn a corner and for seemingly no reason it would drop down again. Upscalers pretty much dented the frame rate more than they helped, hence the native resolution in FXAA here. But yeah, 27 FPS on average, 1% lows down to 23. I didn't think it was going to be able to do it, and unfortunately that's the case. Red Dead Redemption 2 is remarkably well optimized and does tend to know the settings it wants to run with, and it ran with a mixture of medium and high and ultra. Textures were on high, a lot of the reflection and lighting effects were on ultra, and a few of the particle effects were down to medium, so it seems fairly well set up out of the box, because it gets you in and around 34 FPS on average, and 1% lows down to 30 FPS. In a similar vein to Cyberpunk, it's one of those games where you wouldn't think it's going to run this well and look this great, and then you launch it and you're like, you know what, that's actually pretty playable. Once again, I'd put a 30 FPS external cap in place and call it a day. It runs pretty good, and I can't really argue with the visuals it's producing. So for an integrated graphics card to be getting close to maxing out Red Dead Redemption 2 in certain areas, it's pretty good going. In terms of those Battle Royale competitive games, PUBG's DirectX 12 mode does work really well on these integrated Intel Arc graphics, resulting in very smooth frame times, albeit frame rates that will be in and around 60 FPS most of the time. With low settings, which is how most people are playing this game regardless, in a 1080p resolution, we returned 58 FPS on average, and 1% lows down to 53 FPS. So PUBG, overall no problems, but you are going to need to use the DirectX 12 renderer to be able to get these excellent frame times. Generally, DirectX 11.1 and DirectX 11 mode will net you a higher average, but you will suffer when it comes to 1% lows. This is the same on virtually most cards these days, especially if you're running something Intel-based like the integrated Arc graphics, but still, for a game that pretty much no one was able to run on launch, now running on integrated graphics with the settings everyone's using, can't really argue with it. Next up we have City Skylines, because this is a good test of the single core performance. City Skylines 1 is Unity based, so it means it is very heavy on cores 0 and cores 1, which of course with the Core 9 Ultra in this mini PC means that it will quite comfortably boost up to 5.1 GHz when you're utilising speed up, which I was most of the time, on those two cores, and we were running with the FPS boost mod, which is something that you need to fix a UI bug, but with all this in place and the game pretty much maxed out, we returned 59 FPS on average, 1% lows down to 50 FPS, and once again I got carried away playing it because it just runs that well. In the end we were able to expand our city slightly more by a couple more tiles, and use a very bodged solution with highways coming off in random places to fix the traffic problem, which inadvertently also fixed the industries that were struggling to get resources in problem. So now we need to grow the city a little bit more to be able to buy the next tile up, so I can fix the top end of the city, but still, City Skylines, perfect opportunity to actually grow our city a little bit more, the benchmark town we're using, and you're going to be getting a 60 FPS experience. I don't know what it is with Intel Arc, but it doesn't get on particularly well with any form of Crysis. Whether it's the original release where it doesn't seem to run it quite right, or if you're running the remastered version where it turns it into Doom. When you weren't looking at the broken skybox, you'd get in and around 60 frames per second, but the moment you were looking at the hellscape drawing in from the sky, it would drop down to just in and around 5 to 10 frames per second, and GPU utilization would drop immediately. So I'm going to say this is something driver side, but yeah, Crysis Remastered, I don't really know how to fix this. I tried workarounds, but they just weren't working for me. But finally, a beautiful point to round off with Mountain Blade Bannerlord, which defaults to a mixture of high and very high settings in 1080p, and the battle size also set to the highest it will go. Makes sense, the processor in this is clearly able to handle much bigger battles than what's going on here, because the Core 9 Ultra is just, well, stunning performance. You can't really argue with the level of processing power this has in such a small package. I know Ryzen is the thing to be talking about right now, but I really do like the 185H. It's a processor I've been using for a while, and this is one of the reasons for it. When it needs to boost up, it can, and when you're throwing it into these very simulation-y style games, they deal with it great, and these are the types of games that I mostly play. But still, we return throughout the built-in benchmark, which is reminiscent of the late game, 50 frames per second on average, 1% lows down to 36 during the flyover sequences where it really is struggling on the memory bandwidth of the graphics card available, but still, it ran pretty much perfectly. So, overall gaming performance. Well, in standard GEEKOM fashion, they've taken what is already a very good chip, and they've souped it up enough that they're now eking out even more performance than last time we've actually witnessed one of these. So yeah, it's a workstation device. Yes, we will get into the workstation testing in a moment, but at the same time, when you actually throw it up into some gaming benchmarks, it deals with it with no problems. I mean, the idea that this is your workstation PC designed for video editing, AI hosting, media station tasks, NPU tasks, all of those boring, mundane, day-to-day things that we have to get up to, then you can actually go onto it and play GTA 5 with pretty much ultra settings and no problems. You can load up Counter-Strike 2 and actually be decently competitive. You can load up Arc Raiders and it's gonna look great. I mean, the fact is, you can play Red Dead Redemption 2 or Cyberpunk with no problems on this. So yeah, it is a little bit of a gaming powerhouse as well, which is not one of the takeaways I was meant to have from this, but it's also the first opportunity I've had to look at BeamNG version 0.39, which, as I've heard online, a lot of people are struggling to run this, but hey, we didn't even have to drop to lowest settings, and we know how intensive on bandwidth this is, and we still got a playable experience out of it. So yeah, it's not a gaming PC, but that's not to say you won't be able to do a decent chunk of gaming on it. However, when we move away from gaming, I really do think one of the big standout areas on this mini PC is for editing workloads, and I say this as someone that uses a very similar model to this every day. It has really transformed how I edit videos. I mean, you can see the difference. We now upload in 4K 50 or 60 frames per second because it just deals with 4K footage with no problems. You can just throw these 4K files into Serif Movie Plus X6, which, keep in mind, is an entirely X264 based workload. There is no easy way around hardware acceleration. This is brutal 4K editing being done with just the processor alone. A lot of the effects are single-threaded, and that will definitely come into play when it comes to rendering times. But how does it deal with it? Well, I already knew it'd be fine, but it deals with it beautifully. You can import files that are full 4K, edit around with them, doesn't matter whether they're lower frame rate 25 frames per second or my capture quality of 50 frames per second, it is going to deal with it beautifully. So if you are looking at editing, it can deal with the most brutal way you can do it possible with no problems. Meaning that if you throw up into the world of Premiere Pro, DaVinci Resolve, any modern editor, Sony Vegas even, if you throw up into anything like that, it's going to deal with it fine. So video editing is really where this stands out. If you are looking for a video editing PC, it is going to power through everything up to 4K with no problems, and you have all the codecs available to deal with more modern formats if you wanted to use more modern software. But to be fair, as far as stressing something out when it comes to video editing, being able to do real-time 4K in serif is certainly a challenge, and it is able to do it. Now, the Intel QSV encoder is also another standout. A lot of the time when I'm utilizing it, I do utilize it in Handbrake to prepare my files for editing. Yes, it can deal with the raw files straight off the camera with no problems, but it's nice to have everything in the same file format, especially when it comes to the end render time. So Intel QSV is included, and when comparing it to NVENC and AMD VCE, there's a reason why I pretty much can't move away from Intel these days. Because QSV is that good if you are doing anything regarding recording or transcoding. Then again, there is also the additional fact that Intel QSV is exceptionally good at low bit rates. So I did launch up the original Crysis. Keep in mind, the original Crysis runs really badly on these chips, but I was able to do some 3000 kilobit per second Intel QSV quality recording just to see how it would deal with a low bit rate scenario. This was auto captured at 50 frames per second, so it's also particularly brutal in that aspect. And you know what? If you are someone with bad internet, having a good encoder means that you could technically stream decent quality with only 3000 kilobits per second upload. Which, to be fair, is something I'd imagine most people have these days, but given that's how I used to stream back in the day, I could never imagine getting anywhere near this level of quality. So yes, Intel QSV works exceptionally well, and I mean, it doesn't matter whether you're doing streaming, recording, or transcoding, it makes it rather good for media tasks. I mean, it'd be overkill for just a media player, but it's going to transcode through those files at around double speed. It should also be noted that the device is pretty much silent. I will get into some thermal testings in just a moment because I have all of the power consumption and thermal figures to get into, but if you are looking for something for audio work, once again, you can pretty much rest assured that it's going to be pretty quiet, especially if you're doing audio-based workloads. So I went through and did some recording. In fact, a lot of the audio that you'll be hearing in this video was recorded on the GEEKOM PC because I want to see how it get on with my usual workflow. Now, one of the most convenient things about modern-day audio editing is the OpenVINO package, which is where you can sort of use AI to remove noise from the background of a clip. I know some people are very reluctant to get into the world of AI, but frankly, compared to the old methods, this is quicker, sounds better, and it works better. This is exactly what AI should be used for. Now, you do get an included NPU, which is ideal for running smaller AI models like OpenVINO. And what does this mean? Well, in layman's terms, it means that you can do the audio reduction, well, noise suppression in the background for any of your clips. Say if you take a 2-minute clip, and it'll be done in around half a second. That is exactly what the NPU is there for. Those boring, simple, small model tasks, it's going to be over within seconds. So before you've even realized, boom, noise suppression done, which is one of the reasons why I love it, because it just saves time. Speaking of the NPU though, I did try and run some AI models, and it is quite comfortably able to do smaller models with no problems thanks to the 24GB of DDR5 memory. Now, some of the newer and more intensive models are completely out of the question. Genuinely, it will just load and load and load and load, but you are essentially overflowed into using the NVMe storage as RAM at this point, and it will get there eventually, but it's going to take a long time. If you run simpler models or smaller models like the Gemini 3 model, I believe I was running, which will run actually remarkably speedy on it. However, it wasn't exactly the best model in the world to be running. I'm sure with some more in-depth practice you could definitely host something that's a bit better than this, but I did just want to cover all those bases and see if it could do it to give you an idea if that's something you're interested in. At the end of the day, it's not quite on the level of the GEEKOM A9 Max AI edition, which is designed for AI models. We looked at it a little while ago, but it is something it can still do. So the same way it can game, it can also do AI models, but workstations is where it shines. if there is one area that I've come to appreciate GEEKOM's workstation PCs, it is for the pretty much near silence of them, and also the thermal performance as well, because when you actually look at the thermal graph that we've gone ahead and done, you're looking at around 70 degrees when running workstation tasks constantly, so think your video rendering, your transcoding bits and pieces, and the hottest you will see this get is in and around the low to mid 80 degrees when you are purely stressing out the CPU. That is the most intensive task for this, because it's allowing it to boost crazy high. In fact, that's why it scores higher than a combined stress test peak, because that way you're balancing the load between the CPU and the GPU, but when it's just the CPU alone that's allowed to boost up, it can get a little bit toasty, but keep in mind, the low 80 degrees, given the actual package this is in, is not particularly bad, especially when some of its competitors, you're looking at around 95 to 100 degrees. I have to give GEEKOM credit, they certainly do manage to make these things able to sustain their boost loads rather well. So how is power consumption on the device? Well, you're looking at around idle to low-end usage of anywhere from 7 up to around 40 watts. It's nothing actually too bad, and stressing out the graphics card by itself, it'll briefly touch 39 and then calm down. General workstation, day-to-day in gaming, you're seeing it hover around 40 to maybe 55, 60 watts, which is actually not too bad, and the highest we actually got it recorded at the wall was during the combined stress test peak when both the CPU and GPU boosted up, and it briefly touched 71 watts. So yeah, this thing isn't going to use much power, which means that if you're going to be sat around all day using it for workstation tasks, that maybe is something to consider. It might take a little bit off your power bill. I mean, to be fair, mine just sips at power all day and I don't really pay too much attention to the power it is using. So there we have it, the GEEKOM IT13 MAX, and to be fair, I do really like it for what it is. As a workstation mini PC, it's kind of what I'm very familiar with, and I have a lot of praise to give them given that it really transformed my workflow when it came to making videos on the channel. I mean, once again, you can quite easily see the step up in quality to where we are now able to do larger, longer, 4K and high refresh videos with ease, which is something that I was struggling to do on simpler and older systems, because I mean, I edited on an FX 4300, then a Skylake i3, then we moved up to Ryzen, then the 3700X, and out of all of these, I would rather have the 185H, which is a great Core 9 chip, and it's one that can be found in the IT13 MAX. So if you're someone that's definitely looking at video editing and that style of workflow, I have nothing but praise to give it, because I've got about a year and a half, 2 years worth of experience using a similar device, and it has been rock solid. And that is kind of the main thing that GEEKOM is trying to give you here. It's a rock solid mini PC that isn't going to go wrong, you've got a good degree of support for, and they're currently running sales on. So they've sent me some links over to whack in the description if you're interested. But really, and I'm saying this genuinely, if you are someone looking at buying a small PC for workstation tasks, anything from Excel to video editing through to audio workloads, this will do everything absolutely fine and very quickly. So I do have a great degree of praise for it, and them including 24 gigs of DDR5 in the year of 2026 when it's almost impossible to find seems remarkably good value. So anyway, thank you very much to GEEKOM for making this possible. Hope you've enjoyed the video. Once again, I absolutely love testing the Intel Arc I GPUs because I think they're phenomenal performance. I mean, they beat out some of AMD's cards, yet no one's talking about them. They are really solid. Anyway, thank you to GEEKOM for making this video possible. Thank you all very much for watching, and good night.